Okay, all right. So here's what we're gonna do. So after you saw Professor von Schmohawk's review yesterday, today we're going to talk about when to use what. So now that I have to assuming that you know all three fluently, meaning graphing, substitution, and elimination, over the course of the next 2 to 3 days, I'm going to show you all the questions all mixed up in a bag. And then if I show you the question, do you know which method to use? Okay, because that's just as important as being able to do one or the other. Okay, so let's give that a try. Let's go. Okay, all right. So I'm gonna try to keep this video short. Yeah, I've said that before. All right, so yeah, I'm gonna try to keep this video short. Not sure how short because I always got something to say. So, all right. So, what I want you to get out of today, all right? Most importantly, when do you use substitution or elimination? I mean, because the graphing thing, most of the time, if you have the graph on the Regents exam, they're gonna let you know they want you to graph. Okay, so most of the time we're really dealing with a elimination versus substitution dilemma. All right. Now you don't have to copy any of this, maybe except for this. All right. Let me get my rainbow. Now, how about flowers? Yeah, flowers right here. All right. So write this down. Okay. So I thought about this a lot actually when I was planning this, and I did some research, and that seems to confirm what I was trying to say. All right. So elimination. Let me use a pink marker. I don't know. Wow, I have to go through all this. Okay. All right. So, all right. So elimination, right? So let's talk elimination versus substitution. So elimination is best used when you have both forms, both equations in a standard form. All right. Meaning first equation and the second equation is exactly the same. And the reason is because you can, with that method, you can just compare the two x terms and the two y terms and make a determination of one of three things, right? Remember what elimination? You could either add them immediately, you can subtract them immediately, right, to cancel one of the terms. So that's a type 1, right? A type 1 elimination is something like that, right? Where you hardly really do anything or make any changes to the equations. Whereas a type 2 elimination is you have to multiply one or the other. So like it's kind of like that in this case, actually. You have to multiply the second expression by 2, and then you subtract, so on and so forth, right? So that's the second one, right? Sometimes you have to multiply by a number, right? And then the third type then is you have to multiply something to both of them. So let's say this was a 3 and that's a 2, then you have to multiply by 2 and 3, right? Remember to get the LCM, right? As an analogy, right? So that's what you would have to do, right? So that's elimination. So again, to summarize, elimination is best used when it's in standard form, when both the equations are in standard form, okay? And then secondly, with substitution, it's best when one of the variables is isolated. So for example, in this case, right, if I give it well, I don't have to give it, it is already in standard form, then the second equation is not in standard form, right? That's in slope-intercept form. In this case, right, y equals mx plus b. Here, you can tell that this right here is isolated. So meaning you can just substitute that right in. So for example, you can take this expression and then put it right where y used to be, right? And then you would get x minus and then 5 minus x equals 3, so on and so forth, okay? So that's that's really it between the two. And lastly, with graphing, right? I want you, actually, I'm just going to read this to you. So graphing is less exact and takes more time, right? Of course, you have to, and the reason why that's the case is because with graphing, you need both equations to be in slope-intercept form. So you put it into the calculator, right? You have to read the table of values, right, and find it, and find the solution. So use this as a last measure, okay? Don't go to graphing too often, okay? Not for no other reason than that these have to be in slope-intercept form, okay? So again, right? So elimination is better than substitution, is better than graphing. And again, elimination is preferred over substitution because it helps you solve questions much quicker. Okay, because even with substitution, you still have to convert the form sometimes, right? So imagine trying to do substitution with this, right? You have to isolate one of the variables and then substitute and then solve. Okay, so that's why elimination works best because sometimes it's just so obvious. Look here, right? It's just so obvious that you can just combine them and cancel out the negative y with the positive y. So that's why this is highly encouraged, okay? All right, now let's see how we're doing on time. Maybe that's enough because I really want to get to the mixed practice with you guys. All right, so yeah, let's stop it here. All right, that was 6 minutes. Come back to class and we'll just practice a lot, okay? All right, see you there.
OMG, that was so good.